Now that we can determine if two given equations are parallel or perpendicular or neither, now we want to know how to actually write the equation of a parallel or a perpendicular line. So the nice thing is we're going to use the exact same steps as we did in our previous objective. So if we want to write an equation, first thing we need to do is find the slope. Then we need to plug into point slope formula, both the slope and one point. Then we're going to distribute and solve for y. So notice that underneath finding the slope in our previous example, we found the slope by using the slope formula or by using the slope that was given to us. Now, oftentimes with parallel and perpendicular lines, we're going to be given an equation. We're going to have to find the slope of that equation, then determine what the slope of a parallel or perpendicular line would be, and use that slope for a parallel or perpendicular line to write our equation. So I'm going to go ahead and let's work through example 1. So please make sure you watch examples 1 and 2. And then example 3 and 4 are like bonus examples. So if you're not quite sure if you've got it or not yet, you're not quite sure if you're comfortable with it, please make sure you do watch them or pause those and try those on your own and get that immediate feedback on how you're doing on it. If you feel like this really makes sense to me, then go ahead and just watch the first 2. But going ahead in the first one, and so I want to write an equation that goes through this point but is parallel to this line. Well, if you remember, I need two things to write an equation. I need a point and a slope. Well, I have the point, but now I need the slope. Well, so what I'm going to do is I'm going to look at what is the slope for my given line. So I'm going to go ahead and I'm going to actually write for my given line. So for my given equation, I have a slope of 3. So it told me to write a parallel line. So for a parallel line, I should also have a slope of 3. So I'm going to go ahead and use that along with this given point to write my equation. So step 2, once I know what my slope and my point are, I'm going to go ahead and say y minus y1 equals my m times my x minus my x1. Well, now I'm going to go ahead and distribute that 3. I'm also going to change minus a minus 6 to plus. And now I'm going to solve for y by subtracting 6. And I get y equals 3x minus 12. Again, in class, if you draw my attention to the fact that you just watched this video, I would love to show you how these two lines do appear as parallel lines, and this line does in fact pass through this point on a graphing calculator. So please, again, make sure you draw my attention to that so you can actually see what that looks like graphically. You could also, of course, graph it by hand on scratch paper if you wanted to. Looking at example 2, very similar to example 1, I'm given a point that I'm passing through, I'm given a line, and now I want to write an equation for a line that is perpendicular to this. Well, I know to write an equation I need a point and a slope, so I'm going to go ahead and I'm going to determine what is the slope of my given equation. Well, lucky for me, my given equation is y equals m in mx plus b form. If it wasn't, I would have to change it to that first. But since it is, I can pick out my slope as -2. So if I wanted to write a perpendicular line, I also need to know the slope of that. Well, since perpendicular lines have slopes that are opposite at reciprocals, I know this is -2 over 1. So I'm going to change it from negative to positive, and I'm going to flip it. And now I'm going to go ahead and plug in, I don't think I can get them both on the same screen. I'm going to go ahead and plug in to this y minus y1 equals m times x minus x1. So y minus my y1 equals my m times my x minus my x1. I'll go ahead and start by distributing. Well, I know 1/2 times x is just 1/2 x. I know that half of 6 is 3. If you needed to, you could do a little scratch work. 1/2 times 6, using that reduce first method, I do get 3 over 1, which is just 3. Solving for y, I'm going to add 2 to each side, and I get y equals 1/2 x minus 1. Looking at 2 more examples, one with parallel and one with perpendicular. Again, these are great examples for you to try if you feel like you're starting to maybe understand this a little bit. So in example 3, First thing I'm going to do is I'm going to have to find the slope of my given equation. Unfortunately, this one is not written in y equals mx plus b form, so I'm going to go ahead and rearrange this first. So I'm going to subtract 3x. I'm going to divide by 4. And I get y equals 2 minus 3/4 x. So it looks like the slope for my given equation is m equals negative 3/4. So if I want a perpendicular line, I'm going to look and say that my slope of my perpendicular line should be m equals, I'm going to take its opposite, so I'm going to make it positive, and I'm going to find the reciprocal, which is flipping it. So 4/3. Now I'm going to go ahead and use my point slope formula and say y minus y1 equals m times x minus x1. I'm going to distribute in the 4/3, and I get y minus 8 equals 4/3 x. 4/3 times 1 is just 4/3, so minus 4/3. From here, I still have to get x by itself, so I'm going to go ahead and add 8 to both sides, which is the same thing as adding 8 over 1, and I've kind of ran out of room underneath it, so I'm going to kind of break my own rules here and drag my work over to the side and say that if I want to add fractions, I know that in order to add a negative 4/3 to an 8 over 1, I'm going to have to get a common denominator. So I'm going to multiply top and bottom by 3, leaving me over here plus 24 over 3. So I get y equals 4/3 x, combining my two constant terms, a negative 4 and a positive 24, signs are different. I subtract to keep the sign of the bigger number, and I get plus 20 over 3. And that will be the equation of a line perpendicular to 4y plus 3x equals 8. Looking at one final example, very similar to example 3 in the aspect that I am not in y equals mx plus b form. So I'm going to go ahead and get there first. And I'm going to do that by first distributing the 5. So I'm going to do my work over here and say 5y plus 10 it won't let me erase that, so I'm going to have to cross it out. My eraser won't let me activate it. So 5y plus 10 equals 3x. I want y by itself, y equals mx plus b form, so I can pick out the slope. So I subtract 10. And now I'm going to go ahead and divide by 5. And I get y equals 3 over 5 x. 10 over 5 reduces to 2, minus 2. So my slope of my given equation is m equals 3 over 5. And so it is supposed to be a parallel line, so the slope of my parallel line will also be 3 over 5. So I'm going to go ahead and plug into y minus y1. So y minus y1 equals m times x minus x1. I'm going to go ahead and step 3 distribute. 3 over 5 times x is just 3 over 5x. 3 over 5 becomes just 3. And again, I'll do a little scratch work here to show you. So I'm going to change pen color and do a little scratch work down here. 3 over 5 times 5. My 5's using that kind of reduce first method cancel, leaving me with 3 over 1, which is of course just 3 as I wrote here. Going back to my main problem, to get y by itself, I'm going to add 1, leaving me with y equals 3 over 5x minus 2. Signs are different, so I subtract and keep the sign of the bigger number. So once again, just to recap before the end of this video, I am using the same steps as before. My first step in finding the slope does take a little bit longer than it did when I was simply given the slope or when I was just putting into slope formula. But other than that, it does have the same steps. Just make sure you are really careful about organizing that slope data. Again, bring this with you to class and you can use it as an aid when doing your practice.